Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael Sindinechi. Today we are continuing with our series, Self-Test, Part 3. Like we said earlier, this self-test will help you to assess yourself to know how far you understood the lectures. It will also help me to know the best way to go about delivering this lecture. We have, started this for some time now. We've done part 1, part 2. Today we are looking at part 3 of it. And the engineering lecture series will be glad if you participate. So today we are continuing with our, computer aspect of the lectures. So say 1, a 2x2 of 1 of 4 decoder can address a maximum of how many registers? Say 16 registers, B 64 registers, C 256 registers, and D 1024 registers. Now, say the answer is A. How did we come about the answer being A? When we say out of 1 of 4 decoder, it means the decoder has 4 outputs and 1 is selected at a time. If 1 is selected at a time, it means that there are possible 4 selections. And when you have that possible 4 selections and it is a 2x2, meaning that the column decoder will have 4 outputs, that is A0, A1. So A0, A1 can be 0, 0. It selects one output. A0, A1 can be 0, 1. It selects another one. A0, A1 can be 1, 0. It selects another one. A0, A1 can be 1, 1. It selects another one. So you see that the column decoder will have 4 combinations. The row decoder will have 4 combinations. So you will now say that it's 4 times 4, which is 16 registers that can be addressed by the 2x2 of 1 of 4 decoder. Now, if we, extend that same thing, when we talk of 3x3 decoder, it means that we can have maximum of 3 bits, that is 0 to 7, which is 8. That is why you can select a maximum of 1 out of 8. That is the meaning of 3x3. That is 3 bits by 3 bits, which is, 3 bits in binary is maximum of 8. That is from 000 to 111. 000 is 0, 111 is 7. So 0 inclusive to 7 means 8. That is the meaning of this 3x3. And this 3x3 can select 1 out of 8. So just like before, we say 8 times 8 will give us 64. So the maximum registers that can be addressed by 3 of 1 of 8 registers can be maximum of 64. That is 8 times 8, 64. So we want you to understand it very well so that anytime you see decoders, even though we are going to do more work on our subsequent lectures on decoders, but we want you to understand anytime you see that, what it will be. So 4 by 4 of 1 of 16. So if you see 4 by 4, if you have 4 bits, you can address maximum, or you have possible maximum of 16 combinations. That is 1111. In hexadecimal is 15, but in decimal it will be from 0 to 15. If 0 is inclusive, it means you have 16 rows. So in this one, you can now convince yourself that the maximum you can address will be 16 times 16, which is I think 256. So you can see the maximum you can address is 256, which we shall see. So if we go again, we can also see 5 by 5. If you have 5 bits, it will be possible 52. So the possible register you can address will be 32 by 32. So that gives your answer as D. Sorry, the last is D. That is 1024 registers is D. So sorry for that. So what is the disadvantage of a RAM? In the first instance, we say that RAM is random access memory, that we have 2 primary memories in a computer, the ROM and the RAM. And so now, what is the disadvantage of this RAM? So A, it is non-volatile. B, it is volatile. C, it is magnetic. And D, it is non-magnetic. So for us to arrive at the answer, we know that we said the ROM, read-only memory, is non-volatile, because if the power goes off, the content of the ROM is sustained. And we have said previously that the CMOS battery is what sustains the ROM. But the RAM, anytime the power goes off, the content is lost. And that was what we termed volatile. So you see, it is a disadvantage in the sense that if you are doing some work and you didn't save it in the secondary memory device, if your power goes off, the whole thing you are doing in the RAM will be gone. So the disadvantage is that it is volatile, and our answer is B. So one of these is not a program function. A, data transfers between the main memory and the CPU registers. B, arithmetic and logic operations on data. C, program sequencing and control. D, debugging of memory address. And we say that our answer is D. The program doesn't debug memory addresses. The memory address remains what you feed it to be. So continue. This instruction format, add X, Y, Z, is what type of addressing format? We say a 4 address format, a 3 address, B, a 3 address format, small mix up. C, a 2 address format, and D, a 1 address format. So which one is it? Is B. B, the first B, a 3 address format. A 3 address format in the sense that in one line you have 3 addresses, X, Y, Z. In other words, what you are trying to do is you are telling the system to add the content of Z to the content of Y, that is, add whatever data is in the Z register to the content of Y register and store the answer in the X register. That is the meaning of that. So it is 3 addresses in one line. So again, say which of this is a 2 address format technique? A, load X. B, move X, Y. C, add X, Y, Z. And D, store accumulator F. Now, let's look at it. A means that for you to do the similar thing we have in question 7, you have to have 3 addresses and written in 3 lines. The first one will be this load X. You take something to a data to register X, you will now say add Y. Then you will get what is in Y and add to it and store in X or Z before you complete what the instruction in 7 is doing. So you will have to write 3 different lines of instructions to achieve that if you use what you have in option A. What we have in option B is move Z, Y. So you see that if you say move Z, Y, you are moving what is in Z, what is in Y to Z, and it will, add to what is there. Then you need to write another one to say stop. So you see that that is a 2 address format. You must have 2 lines. Of course, C is what we did in 7, while D is store accumulator HF. You are moving the data HF direct to the accumulator. So B is the 2 address format technique. Then it says load and store instructions are used to implement what? Input functions only, output functions only, memory functions only, input and output functions. See that our answer is D, because when you say load, you are taking something from either the input to the register, or when you say store, you are storing something in probably in your output device. So these commands, load and store, are mainly used for input and output functions. So the next is all the machine instructions that are provided by a given microprocessor are termed as its what? Peripheral devices, instruction format, instruction set, instruction size. Of course, we know, as we say, that it is the instruction set that all for a given microprocessor, you have a set of instructions that you can use to, address and command that microprocessor to perform. So we call that its instruction set. So next one, the general purpose CPU register is called what? A stack pointer, B the accumulator, C the flag, and D the microprocessor. Of course, we know that is the accumulator. We say that it's a general purpose register where all the arithmetic and logic unit operations are carried out in the CPU, and that is called the accumulator. Now, a typical subroutine instruction include all but one of these: A, go sub, jump to sub, call sub, exit sub. When we are talking of memory instructions and addressing, we talked about subroutine, and we said that there are some commands used in subroutines, standard commands, depending on the microprocessor, that we have the go sub command, we have the jump to subroutine, we have the call subroutine, but we don't have exit subroutine. Instead, what we normally have when you are going out of subroutine is a return command. Return takes you back to the top of the place where you jumped out to carry out a subroutine instruction. So there is no command like exit subroutine. Rather, what we have is return command. So it says which of this is true? A, in a conditional branch, the branching will occur only if a specified condition is met. In a conditional branch, when you're writing your program or when your computer is executing a function, in a conditional branch, the branching will occur only if a specified condition is met. B, in a conditional branch, the program always departs from the normal sequence and fetches the next instruction from a different address location. C, in an unconditional branch, the program always departs from the normal sequence and fetches the next instruction from a different address location. And D, in an unconditional branch, the branching will occur only if a specified condition is met. So we have four options. Two of them talked of conditional, two of them talked of unconditional. So we now, look at it that in a conditional branch, in other words, there is a condition to be met before the branching will take place. And recall that we said branching instruction mostly occur when you have a subroutine. So when there is a condition, the branching will occur only if that specific condition is met. If that condition is not met, the program continues to run without branching or going to the subroutine. So you see that A is the correct answer, because in the second one, the program always departs from the normal sequence and fetches the next instruction from no. That condition must be met. That is what makes A, the correct answer. And of course, C, say the unconditional branch, the program departs from the normal and fetches the next instruction from, and D, an unconditional branch, the branching will occur only if a certain condition is met. No, because it is unconditional. There is no condition stated. Now, every subroutine usually ends with the exit instruction, return instruction, close instruction, end instruction. We just answered that before now that it is return instruction. So our answer is B. The push operation of a stack can be thought of as the result of inserting a new item onto the top of the stack. B, as the result of deleting one item from the top of the stack. C, as the result of decrementing one item from the bottom of the stack. D, as deleting the whole data in the stack. We say our answer is A. Now, let us get what we mean by stacking in computing. In computer terminology, we say that things like first in, first out, first in, last out, last in, last out. Now, let's get the clearer picture of it. If you're washing your dishes, let's say your flat plate, you wash the first one, you put it, you wash the second one, you put it on top, you wash the third one, you put it on top. So what you are doing is stacking that plate you have washed. The computer does that when you are bringing information to the storage device. It will be stacking that information. Now, when you want to collect that information, if you want to do it sequentially, you will remove the one on top first. That one on top is the last one that came. So what you are doing is last in, first out. If you find a way of carrying the thing up to remove the first one you washed, it becomes first in, first out. Now, when the computer is working and making use of this stack, it uses two commands to operate there. One is the push command, the other is the pop command. So this push command means that you are inserting a new item onto the top of the stack. Now, if that stack is, of the same size, it needs a spring under. I want you to imagine that. It needs a spring under. So if you remove the one on top, the spring pushes and another one comes to the top. So you see, that push operation means that you are inserting something on the top. As you do that, you push the spring down so that you'll be able to insert another one, so that you'll be able to insert another one. So we call it, when you are doing the stacking, adding on top, you are pushing down. When you are removing from the top, you are popping up. When you remove the one on the top, another one pops up to that point. So it is good for you to know that in stacking and stack operations, which we say that the computer uses a stack pointer to show what is the next operation to be done. So I feel with that, anywhere you see stack, you know of stack pointer register, you know of the two commands, the push and the pop, And what the push means that it is inserting a new item on top of the stack. And the pop means, either deleting from the top or moving the thing up. So um, you see now, the pop operation of a stack can be thought of as a result of inserting new item on top of the stack. What we said is for push. As a result of deleting one item from the top of the stack. You can see that when you remove one, you say you pop up. C, as a result of decrementing one item from the bottom of the stack, and D, as deleting the whole data in the stack, of course, no. So our answer is B, as the result of deleting one item from the top of the stack. When you remove one, the next one pops up. That is the two commands you have in your stacking and stack registers of a computer. Now, 16, computer registers use shift operations to perform multiplications and divisions on bits. What do you think? Yes or no? Of course, the answer is yes, because I say that it does a shift to the right or a shift to the left corresponds to multiplication or division of the number being shifted. Now, 17, the addressing mode in which the operand resides in the memory and its address is given directly in the address part of the instruction is called what? Immediate addressing, index addressing, direct addressing, or implied addressing. So we say that our answer is direct addressing. So I want you to, go back to our lectures and get to understand all the addressing techniques. It is very necessary for you to, make impact in your machine language programming. So now, but the immediate addressing is, like we say, load immediate a data. It takes straight to that, but direct addressing is like that example we have given in the 1 or 2 address format. For instance, say the instruction MVIZ5E is a form of one, index addressing, immediate addressing, relative addressing, indirect addressing. Is a form of immediate addressing because look at it, MVI means move immediate. The number 5E in hexadecimal to the register Z. That is just that command. So you can see how machine instruction works. You have said MVI. Remember, for different microprocessors may have different commands. That was why we said you study the instruction set of the microprocessor you are using. But if we take this to be a typical microprocessor, it means MVI means move immediate. Z5E. See, 5E is a hexadecimal number which entails 8 bits. We have said in our previous lecture that if you have a number in hexadecimal, it is easy to get the binary equivalent. For instance, E is 1110 in binary, and 5 is 101. So you now move 0101, 1110. That is the bit you will move to the register Z. So that is immediate addressing. You are not telling the thing to get data from another register and send to another register. You are moving data direct to register Z. So immediate addressing. 19, the instruction add z x is an example of direct addressing, index addressing, zero page addressing, indirect addressing. Of course, it is a form of direct addressing. You're adding what is in X to what is in Z, and your answer will be stored in Z. That is the meaning of that. So it's also good for you to know what indirect addressing and index addressing is. So the addressing mode, in which the address part of the instruction specifies the address where the effective address is stored, is called immediate addressing, index addressing, indirect addressing, present page addressing. We say that it is indirect addressing. If you look at the instruction, you see it's a bit, complicated and confusing. The addressing mode, in which the address part of the instruction specifies the address where the effective address is stored. It's called indirect addressing. So just when you're writing your machine language, you meet so many conditions. So it is good for you to know all the possible conditions to help you to address properly the machine so that it does what you want it to do. The addressing technique in which the operand is specified implicitly in the definition of the instruction is known as what? So implied addressing, relative addressing, register mode addressing, index addressing. I would say that our answer is A. It is implied that that happens. Very, very important if you are continuing a career in talking to machines, because this is what we call the machine language programming. So the transfer of data between an external memory device and the system memory is known as what? Relative addressing, register mode addressing, direct memory access, random access memory. Which one? Direct memory access. We talked of DMA, direct memory access, in one of our lectures when we say that the direct memory access helps the system to either move data direct from the input or to the output device without having to bother the CPU. And when that happens, the system acts faster because the CPU is not involved. So call that DMA, direct memory addressing. So flow charting is a convenient way of expressing on paper in diagrammatic form the activities involved in attaining a required sequence in which the activities must be performed, yes or no, of course, yes. That is our description of flow charting. Now, a combinational circuit consists of logic gates whose outputs at any point in time are determined directly from the present combination of inputs with reference to previous inputs. Yes or no, true or false? We say the answer is false. Do you know why? A combinational circuit doesn't make reference of previous inputs. It takes what you input now and finds the combination of it using the type of gate you have fed it into and gives an output. But when it makes use of the previous input, you will now say that it is a sequential circuit. So that is the difference between a combinational circuit and a sequential circuit. A sequential circuit tries to remember the previous input and work together with the current input to give an output. In other words, when we start treating sequential circuits, you will see that it always has a memory. and the least component of a memory is the flip-flop. So every sequential circuit makes use of flip-flops. So we will get to that in our subsequent lectures. So which Boolean identity is correct here? A or 1 equals 1. A and 1 equals A. A or A equals A. A and A equals 1. Which one is correct? We say D. Because A or 1 is equal to A, not 1. A and 1 is equal to 1 and not A. A or A is equal to 1 and not A. A and A is equal to 1. So see that that is the correct one. Remember, when we were doing this lecture on Boolean identity, we say that the identities you must remember, commit to memory. If you don't do that, you will not be able to, do any sequential or combinational circuit properly. You must know this offhand to be able to always simplify anything. So again, which Boolean identity is correct? A or 0 is equal to 1. Do you think? B, A and 1 is equal to A. Do you agree? A or A is equal to A. Do you agree? A and A is equal to A. Which one? If you can, look at 25 and 26 and be able to get the answer and see that the correct identity is A or 0 is equal to 1. The expression A or AB is equal to A represents what? De Morgan's theorem, absorption theorem, logic adjacency, or the associative law. Which one? Of course, from what we said and described, it is the absorption law. That if you simplify that left-hand side, if you bring out A, it becomes A into 1 or B. 1 or B is equal to 1. So what you will now have is A and 1, which gives you answer A, and we call it the absorption theorem. So this expression, not A and B or A and B equals B, represents what? We call it the logic adjacency. And we say that much later, if you want to simplify this mathematically, we will take so many assumptions. So we will be developing the canon map that will help us to just slot this thing and get out what the answer will be without having to bother ourselves to, come up with the assumptions. And please, in our next lecture, this is very important and very interesting. When you use K-map to simplify, you see that no matter the expression you have, you just quickly put your K-map and, the answer will come out, floating. Very interesting topic. So in the next few weeks, we'll be getting to that using logic adjacency. Now, which of these is not a logic gate? NAND gate, exclusive NAND gate, OR gate, an exclusive OR gate. Which one? We have heard of NAND gate, we have heard of OR gate, we have heard of exclusive OR gate, we have heard of exclusive NOR gate, but we have not heard of exclusive NAND gate. So NAND gate, exclusive NAND gate is not a logic gate. Logic OR gate gives a logic 1 output if any or all of its inputs is in the 1 state, true or false. Remember, we drew an analogy of a logic gate, that it is when you have, your switches, as when you have 2 switches in parallel. That is the analogy of a logic gate. In other words, if you have your 2 switches in parallel, if any one of them is closed, current will flow. If 2 of them are closed, current will still flow. So you see that a logic gate gives logic output 1 if any or all the inputs is in the 1 state. So our answer becomes true, A. If the number of input variables to a logic gate is 4, what will be the number of rows in the truth table? We say it could 8, 16, 32, 64. So what do you think? If you have input variables 4, it means you will have, 4 raised to power, 2 raised to power 4 possible combination, which is 16. Logically, if you look at it, you have 4 input bits. It means one can be 0, the other one 0, the other one 0, the other one 0. Then it can be 1, 1, the other one 0, 0, 0. Then the other one could be 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, like that combination. And we say that the number of rows in a truth table is equal to 2 raised to power number of inputs. So if you have 4 inputs, it becomes 2 raised to power 4, which is 16. So our answer is B. If you have 2 inputs, it becomes 2 raised to power 2, 4. If you have 3 inputs, it becomes 2 raised to power 3, 8, and so on and so forth. You say the OR gate is analogous to an electric circuit, electric switches connected in series. Of course, no. We just talked earlier that it is, equivalent to electric circuit connected in parallel. So say an electric circuit without switches, of course, not true. An electric circuit, electric switch connected in parallel, that is true. And electric circuit without a lamp. So our answer is C. The AND gate is analogous to an electric switch is connected in series. That is true. An electric circuit without switches, an electric switch connected in parallel, an electric circuit without a lamp. Of course, it is equivalent to connected in series. So 2 of them must be closed before you have an output. So answer is A. Exclusive OR logic gate gives an output if all the several inputs are in 1 state, gives an output if only one of all the several inputs is in 1 state, gives an output if all the several inputs is in 0 state, and D gives an output if only one of the several inputs is in the 0 state. Because our answer is B. all these are very important, because when you are given the truth table of any of them, it makes it easy for you to fill them if you know what each gate stands for. That for exclusive OR, it gives an output if only one of the several inputs is in one state. And when we were treating that, we drew an analogy when we say that it is equivalent to having an automatic door that we open only when one person is at the entrance. If there is more than one person, uh, at entrance, the door will refuse to open. If there is nobody, it will refuse to open. It will only open when there is only one person standing at the entrance. That is the exclusive or logic gate. So the logic family or the logic gate family that has 74XX 7400 series belong to which logic family? Is it the CMOS family? Is it the MOS family? Is it the TTL? Is it the ECL family? CCMOS stands for complementary metal oxide semiconductor families. MOS stands for metal oxide semiconductor family of ICs. The TTL means transistor logic family, and the ECL means emitter coupled logic family. So which one? We say that it is C, the TTL families, the 7400 and the 5400 series. Then 36, very large scale integration is supported by which logic family? So is it the CMOS family? Is it the MOS family? Is it the TTL? Is it the ECL? We say that VLSI family is supported by the MOS family. See, they have, virtually all the ICs, but each one is very good in something. For instance, the CMOS is very good in conserving energy. That is why it is used as the battery that serves the ROM in the computer. So systems requiring high-speed operations use ICs from which of the families? We also say that it is from the emitter coupled logic family. So with this, I guess you will be very conversant with, when we are talking of ICs and all that. So systems requiring low power consumption use ICs from, of course, from what we said, that is the CMOS family, which gives the answer A. The function of the memory decoder is to do what? To determine which location is being selected, supply the binary address of memory location, of course, no. Activate the control signal, no. Place data on the data bus, no. So our answer is A. The primary function of memory decoder, like we have seen, before in our today's lecture, is that it uses the row and the column decoders or decoding line to select the particular memory chip that you want to access, either write into or read from. So it has no other function other than to use the row column or the other column to decode which chip that is being selected. So if you have 2 by 2, we have seen there that you can select, this number of chips. If you have this, you have that. So just that's the function of the decoder. Which of the statement is correct? Address bus is a unidirectional bus from CPU to the memory chip. Address bus is a bidirectional bus from CPU to the memory chip. Data bus is a unidirectional bus that um, carries data between the CPU and the memory chips. And control bus is a bidirectional bus that carries data from the memory to the CPU. So which one is your answer? Say A. It is important for you to note that the memory communicates with the CPU using three buses. And the three buses are the address bus, the data bus, and the control bus. But the data, the address bus is a one directional bus. If you see where it is drawn, you see just one arrow which goes from the CPU to the memory chip. If you see a line with two arrows, one pointing to the right, one to the left, we say it is bidirectional. That is, can go this direction. The information or the data there can go this direction or that direction. The data bus is the only one that is bidirectional. But in our options here, it says unidirectional. That is what disqualifies C from being the answer. B is disqualified because it says it's bidirectional. Address bus is never bidirectional but unidirectional. And the control bus is also unidirectional. From the CPU, it activates, it goes to the enable or the enable command or enable input of the chip, so that when it sets signal there, the chip is enabled to act. It's good you go back to that our lecture and see that some systems, we say that some systems may use enable, some will use read write, where one input can do the dual function, but one must be high and the other one low for it to act. So I think we are getting to the end. ROMs are said to be non-volatile because they cannot have their data changed once they have been written. The answer is no. The data was stored during the manufacturing process. No. The data stored in them are not lost when power is turned off. Yes, that is why they are non-volatile and they are programmable. So answer C, that is why they are. Part 2, the architecture of a ROM consists of four basic parts. Of course, the registers, row decoder, column decoder, and buffers. I think that is correct. That is what's considered of architecture of a ROM. So registers, vertical decoder, column decoder, buses. Buses are not part of the ROM architecture. There's nothing like vertical decoder, so B is not part of it. C, registers, horizontal decoder, of course, horizontal and buses are not part of it. And D, registers, row decoders, column decoders, and buses. So the first three are part of it, but buses are not. So our answer is A. So I think that's where we will stop for now. Thank you for going through the self-test in the engineering lecture series. It is going to be more regular from now on. For instance, I think later in the day, I will do another self-test on, now mainly on the electrical part of our lectures. That is where we are looking at circuit theorems, alternating, single phase alternating current, network theorems, electromagnetism, electrostatics. So we will start that and do it today and tomorrow. And after that, the engineering lecture series will go on probably 2 weeks break and come back on air with more vigor. But as we continue now, we will always have this self-test series to help people understand, assess how they understood our lectures. It will assist you to evaluate your understanding of the topics already treated. So finally, I normally end with what I call word of advice or word of wisdom, the way it appears to me. And what I want to look at is that general saying that says, a bird in hand is worth more than 10 in the bush. I want to disagree with that. It's subject to, discussion and argument. To me, a bird in hand is still worth less than the other 20 in the bush. Enter the bush and hunt for more. That scale you use to get that one, if you enter the bush where there are 20 of them and apply that same scale, you will see that you will get more, instead of you just being satisfied with the one, just one you have at hand. So I said, please do not strive for less. Do not strive for less. If you have one, there are 1,001 birds still in the bush. Use that scale you used to get one to go into the bush and get more, because one will not be enough for you. If we bring down to this our engineering lecture series and you as our student, we feel that just listening only once may not make you to grasp everything very well. And as student of engineering, you must carry what you learn today to add to what you will learn tomorrow, to add to what you will learn next tomorrow. And at the end of your career or your studentship, you have built a career full of knowledge. So that is what I normally do. So I look at that general saying and see where it is not very, very appropriate. So a bird in hand is still worth less than the other 20 in the bush. Enter the bush and hunt for more. Do not strive for less. Thank you for listening. Please share with your fellow students in other universities, because electrical engineering is the same. It doesn't matter the university where you are. Thank you for listening.